Hi guys, welcome to another video in the preliminary chemistry and chemical earth video series. This one on physical and chemical properties, and this is kind of going to wrap up what we've been doing in the chemical earth and just bring some of the ideas together. So the following couple of videos will just close this topic off. But in order to do that, what we need to do is we need to have a look at just some of the differences between pure and impure substances. So that's where we started this topic, and it's pretty much where we're going to leave it. Firstly, pure substances, you remember, are elements and compounds. So that's what we're looking at or that's what we're thinking about when we're talking about pure substances, that is elements and compounds. And they have consistent chemical and physical properties. Because they're pure substances, their properties are invariant. They don't change. Often you can look them up, but if you test them, you should find some consistency. So when we look at a pure substance like water, we can identify its melting point of 0 degrees C, its boiling point of 100 degrees C, its density calculated by the mass over the volume, which for water is 1 gram per mil, or also equal to 1 kilogram per litre. So it makes it very easy to do calculations with water. Its electrical conductivity, whether it allows electric current to pass through it, and also things like its acidity. Each of these are types of properties that are very consistent when we're thinking about water. On the other hand, mixtures are impure substances, and because they are impure, they don't have fixed ratios, and therefore they do not have fixed properties. Often mixtures are a blend of the properties of the component elements or compounds that make them up. And sometimes those properties are dependent on the proportions of each of the different components of the mixture. So if we think about something like salt water, how salty the water is going to affect its melting point and its boiling point. It's also going to change its density. Its ability to conduct is going to vary with the concentration, with ion concentration. So it's actually going to become more conductive as it has more ions. And even taste is something that can change depending on how salty the water is. You can actually taste the difference. So when we look at physical properties, then these are the things that we're after. The melting point, which is the change from a solid to a liquid. The boiling point, which is the change between a liquid and a gas from either direction. So these can go obviously in either direction. Hardness, which is usually measured on the Mohs scale, where 1 corresponds to talc and 10 corresponds to diamond. Luster is the appearance. So often we will describe appearance in terms of shiny or dull, colorless, not clear. It could be clear, but that doesn't tell me about its color. So colorless, color is obviously another important property, and it's a physical property. Thermal conductivity, so that's how well it conducts heat. Electrical conductivity, this is obviously straightforward. Density, solubility in aqueous solution. So what happens when we throw it in water? Does it dissolve? Does it readily dissolve? Does it partially dissolve? Does it not dissolve at all? These are all physical properties. They're based on the physical bonds between the particles, and for pure substances, they're very consistent. For impure substances like mixtures, they do vary a little bit from one type of mixture to another. When we're looking at chemical properties, we're looking at the ability to combust. So a combustion is a reaction with oxygen often. Corrosive, again, is another reaction with oxygen, a different one. This is an energy generator. Corrosion doesn't always tend to generate very much energy, but it can cause a great deal of destruction. Does the chemical substance readily oxidize, or does it cause other substances to oxidize? Is it readily reduced, or does it cause other substances to be reduced? How reactive is it? Reactivity is often a function of the electrons in the valence shell. Electrons in the valence shell, which tells us, does it readily gain electrons or lose electrons, which relates back to its ability to be oxidized or reduced. And also its ionization energy, which is its ability to lose an electron, and its electronegativity, which is its ability to gain an electron. Now, while these are sort of fairly consistent properties across different pure substances, they do relate specifically to how these compounds behave in chemical, or elements behave in chemical reactions, because they tell us something about what the atom is doing in terms of whether it readily gains or loses electrons. Now we're going to put some of these properties together as we have a final review through each of the main groups of three-dimensional structures, so ionic lattice, covalent molecular, covalent network, and metallic. And we'll just see if we can provide a link between the properties of each of these substances and their uses. Thanks for watching.